Every road you drive on, highways, city streets, suburban lanes, airport runways, and rural backroads, begins as a steaming mixture of crushed stone, sand, and liquid asphalt, heated to extreme temperatures and engineered with microscopic precision. Yet most people never see the enormous industrial process behind paving a single mile of roadway. And today on the How Factory, we're revealing the full journey of how asphalt is mixed, heated, processed, and delivered to construction sites every day at massive scale. It all starts in quarries and gravel pits, where raw aggregates like crushed stone, gravel, and sand are mined and processed. Giant excavators scoop up material and load it into haul trucks that carry it to crushers, which break rocks into smaller uniform sizes. These stones pass through vibrating screens that separate them into different fractions: coarse aggregate, fine aggregate, and mineral filler. The exact blend depends on the asphalt recipe required for each road, because highways, parking lots, bike paths, and airport runways all have different engineering demands. Once sorted, these materials are stockpiled in carefully organized rows outside the asphalt plant. Trucks, loaders, and conveyors continuously feed the plant with the right combination of aggregates. But before any mixing can happen, the aggregates must be dried and heated. They enter massive rotating drums known as dryers, where powerful burners, fueled by natural gas, diesel, or recycled oil, blast hot air through the tumbling stones, removing moisture and raising temperatures to around 150 to 180 degrees Celsius. Moisture is the enemy of asphalt bonding, so drying is absolutely critical. Inside the dryer, flames roar, stones tumble, and dust is pulled through giant filters called bag houses, which capture tiny particles that would otherwise escape into the air. These particles are collected and reused in the mix, ensuring efficiency and environmental compliance. Once heated, aggregates move by conveyor into weigh hoppers, where sophisticated sensors measure exact amounts of each stone size. Precision is essential. Too much fine sand makes the pavement weak. Too much coarse rock makes it rough and noisy. Meanwhile, another essential ingredient is prepared: liquid asphalt binder. This binder is a sticky black petroleum product refined from crude oil, stored in heated tanks that keep it at 140 to 160 degrees Celsius, so it stays fluid. These tanks connect to insulated pipes that feed the asphalt cement into the mixing chamber. To enhance performance, chemical additives may be blended into the binder. Polymers for strength, anti-stripping agents for moisture resistance, rejuvenators for recycled materials, and fibers for durability. With both components ready, hot aggregates and hot liquid asphalt, mixing begins. In batch plants, aggregates drop into a pug mill mixer where rotating paddles stir them together with the binder for 30 to 45 seconds. In drum mix plants, everything flows continuously through a long, rotating drum where stones gradually meet asphalt binder and blend into a smooth black mixture. Reclaimed asphalt pavement, RAP, ground from old roads, is often added at this stage. This recycled material helps lower cost and environmental impact, making modern asphalt production more sustainable. Some plants also incorporate recycled shingles, glass, or rubber crumbs from old tires to enhance strength and reduce waste. As the hot asphalt mix forms, quality control technicians take samples to test temperature, viscosity, density, and aggregate distribution. Too cold and the mix won't compact properly. Too hot and it may degrade before reaching the road site. State-of-the-art plants monitor these conditions continuously with sensors and automated controls, adjusting burner heat, material flow, and mix timing in real time. Meanwhile, environmental systems capture fumes, dust, and emissions to keep the process clean and compliant with strict regulations. Now comes the critical moment: loading and delivery. When the asphalt mix reaches the right consistency, it's discharged into insulated silos that keep it hot and stable until trucks arrive. These silos can store hundreds of tons of fresh asphalt at once. Dump trucks line up beneath the silo gates, and massive hydraulic doors open to release steaming black mix into truck beds. The beds are often coated with a light release agent, usually soapy water, that prevents asphalt from sticking. As soon as each truck is loaded, it heads straight toward the paving site. Asphalt must be delivered quickly because it begins cooling the moment it leaves the plant, and if it drops below optimal temperature, it becomes difficult or impossible to compact properly. During transport, trucks cover their loads with heavy tarps to retain heat. On large highway jobs, fleets of trucks move continuously between the plant and the job site, forming a steady supply chain that keeps paving equipment running without interruption. When trucks arrive at the work zone, the paving phase begins. Pavers, massive machines with conveyor belts, augers, and screeds, take the hot mix from the truck and spread it evenly across the road surface. The truck slowly backs up to the paver, releasing asphalt into its hopper. The paver then pulls the mix under its screed, a long, heated plate that levels and partially compacts the asphalt into a smooth mat. The screed determines the thickness, slope, and initial texture of the road. Sensors and automated leveling systems keep the surface consistent across long distances. Immediately behind the paver, a fleet of rollers moves into position. These rollers compact the asphalt using massive steel drums, or vibrating mechanisms that force the mix into a dense, solid layer. Proper compaction is essential. It eliminates air pockets, prevents future cracks, and ensures long-term durability. Asphalt cools quickly, so rolling must be done in precise stages. Breakdown rolling, intermediate rolling, and finish rolling, all completed before the mix becomes too stiff to compact. Temperature-sensitive infrared cameras often monitor the surface to guide the rolling pattern. Meanwhile, inspectors check density using nuclear gauges or core samples taken later in the process. Behind the scenes, asphalt production relies on advanced chemistry and materials science. The binder's viscosity is carefully engineered through refining and modification. Aggregates undergo hardness and abrasion testing. Mix designs follow strict governmental standards, often developed through laboratory trials where engineers choose ideal proportions for strength, flexibility, and resistance to rutting or cracking. Some mixes incorporate warm mix technologies that allow asphalt to be produced and placed at lower temperatures, reducing emissions and energy consumption while improving workability. Computer-controlled burners optimize fuel use in the dryer, and recycled materials require careful heat management because RAP can overheat if mixed improperly. Asphalt plants run like orchestras of machinery. Conveyor belts humming, burners roaring, silos opening and closing, loaders moving stockpiles, sensors blinking, and operators monitoring screens filled with temperature graphs, flow rates, and batch timing. Plants operate long hours to meet construction deadlines, often beginning before sunrise and continuing late into the night. Safety measures are everywhere. Fire suppression systems near binder tanks, dust filtration systems at dryers, alarms on conveyors, and strict PPE requirements for workers. The entire process is engineered to operate efficiently with little room for error. Once the compacted asphalt cools, it becomes the durable surface we travel on, capable of withstanding heavy trucks, freezing winters, scorching summers, and constant mechanical stress. But the journey doesn't end with paving. Asphalt roads require maintenance, sealing cracks, patching potholes, resurfacing worn layers, and recycling old sections. When a road reaches the end of its life, milling machines grind up the top layers and send the reclaimed asphalt back to plants to be reused, closing the loop and reducing environmental impact. Modern asphalt is designed to be recyclable again and again, making it one of the most sustainable paving materials in the world. Road engineers monitor surface performance through skid tests, roughness measurements, and rut depth evaluations, ensuring each stretch of pavement meets safety and comfort standards. All of this, from quarrying stone to heating binder to delivering mix to compacting pavement, forms a massive industrial ecosystem that keeps cities, countries, and economies moving. And that is how asphalt is mixed, heated, and delivered for roads. A powerful combination of heavy machinery, precise temperature control, engineered materials, non-stop logistics, and decades of road building expertise. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for another deep dive into the hidden processes behind everyday infrastructure.